Hello everyone, welcome back to the Microservices Masterclass. In the previous video, we learned that what is service discovery, why it is needed, how how services register themselves, and how requests are routed dynamically. In today's video, we will explore the tools used in a real world system, how Kubernetes performs service discovery, and what happens when service fails, best practices, common mistakes, and some interview questions. So let's continue. Now that we understand the concept, let's look at the tools. First one is the Netflix Eureka. Netflix built Eureka for a cloud native microservices. Every service register with a Eureka server. When another service wants to communicate, it simply asks Eureka for the latest health instance. Eureka is widely used with a Spring Boot or a Spring Cloud Netflix. Think of Eureka as a phone directory of your all Spring Boot microservices. The next is HashiCorp Consul. Consul is much more than a service registry. It provides service discovery, health check, configuration management, key value store, multi-data center support. If your application runs across different regions or data centers, Consul is an excellent choice. Apache ZooKeeper. ZooKeeper is one of the oldest coordination system. Besides service discovery, it manages leader election, distributed logs, cluster coordination. Although still used in system, although it is still used in systems like Kafka, many modern cloud native applications now prefer Kubernetes DNS or Consul. etcd etcd is highly available distributed key value database. It stores Kubernetes cluster information. Whenever ports or services change, Kubernetes update etcd. CoreDNS reads this information to store service names. Think of etcd as a Kubernetes central database. Next is a Kubernetes CoreDNS. CoreDNS automatically maps this name to the correct ports. Your application simply calls order service. No IP address are required. CoreDNS resolves everything automatically. Next is AWS Cloud Map. If you are running a AWS ECS or EKS, AWS Cloud Map provides managed service discovery. It automatically registers containers and updates their locations whenever they change. No manual configuration is required. Next is Nacos. Alibaba developed Nacos. It combines service discovery, configuration management. It's extremely popular in a large scale enterprise application across Asia. Every tool solves the same problem. How do subs find each other automatically? Next topic is Kubernetes perspective. Kubernetes service discovery. There are 3 order service ports: port A, port B, port C. Each port has its own IP. The problem is the port IPs change whenever port restarts. Instead of exposing ports directly, the Kubernetes creates a service and the service receives a stable virtual IP. CoreDNS creates a DNS entry. Now every application simply calls HTTPS order service. CoreDNS resolves this name to the Kubernetes service. The service automatically balances traffic to the health pods. Let's follow the complete request, how it goes. Client send the request, it goes to the Ingress controller, then it goes to the API gateway. then it goes to the core DNS, then it goes to the order service, then it goes to the healthy pod, and then it gives the response. Notice something important. The client server knows which pod handle the request. Kubernetes take care of everything. That's why Kubernetes application continue working even when the pods are destroyed or recreated. The next section is cloud service discovery. The service discovery becomes even more powerful in a cloud platform. For example, AWS. AWS provides ECS, EKS, Cloud Map. Whenever a container starts, Cloud Map automatically registers it. When it stops, Cloud Map removes it. No manual work. Same way Microsoft Azure Service Fabric and Azure Kubernetes Service provide built-in discovery through DNS. Applications simply communicate using service name. Google Cloud. Google Kubernetes engine also relies on the Kubernetes service or CoreDNS. The process is almost identical to the Kubernetes running on premises. Service mesh. Tools like Istio or Linked extend service discovery further. Besides discovering services, they also provide traffic routing, security, mutual TLS, observability, retry policy, right? Now let's move to the next topic, failure scenario. Now imagine one order service instance crashes. Without service discovery, users would continue sending requests to the failed server. Right? Every request would fail, but the service discovery, the registry continuously receive heartbeats. When the heartbeat stops, the registry marks the instance as unhealthy. It removes the instance. The load balancer immediately redirect traffic to healthy servers. Users never notice the failure. This is called self-healing system. No engineer need to manually update IP addresses. Everything happens automatically. Now let's see the one real world example. Let's see how a large companies use service discovery. For example, Netflix. Thousands of microservices register with Eureka. Ribbon or API gateway discovers healthy service automatically. Amazon massive e-commerce platform relies on dynamic service discovery, so millions of requests can be routed every second. Uber, every ride request interacts with the dozens of the services. Dynamically discovers, ensure the request always reach healthy instances. Spotify constantly scale music streaming services. As new containers start, they automatically register. Traffic immediately begin flowing to them. Now let's see the common mistake. These mistakes beginners often make: hard coding the IP service addresses, ignoring health checks, using very long DNS cache duration, running only one registry instance, not monitoring service health, missing retry or fallback mechanism. Avoiding these mistakes make your architecture more reliable. What would be the best practices? Here are some best practices. Production ready best practices actually. Prefer DNS based discovery. Enable automatic registration. Configure regular health checks. Keep DNS TTL short. Run multiple registry nodes for high availability. Monitor registration and failures. Secure registry communication. Always implement retries and fallback mechanism. There are some interview questions also listed here, like what is service discovery, what is difference between service discovery and service registry, and so on. So let's quickly summarize everything we learned in episode. Service discovery allows microservice to find each other dynamically. A service registry stores information about all running services. Services register themselves and send regular heartbeats. We learned failed instances are automatically removed. Kubernetes uses service and core DNS for discovery. Cloud platform like AWS, Azure, Google Cloud provide managed discovery solution. Service discovery enable high availability, scalability, resilience and self-healing system. Think of service discovery as a GPS of your microservice ecosystem. Instead of memorizing an address, every service asks for the latest location and always reaches the correct destination. In the next episode, we will explore configuration management in microservice, where, where we will learn how to manage environment specific settings, externalize configuration, handle secrets securely, and use tools like Spring Cloud Config Map, and HashiCorp Vault. If you found this lesson helpful, don't forget to like, share, and subscribe. Continue your journey towards the mastering enterprise microservices. Thank you so much.